Hey there! In today's video, we have a comprehensive overview of load balancing algorithms. Have you ever wondered how big web platform handles millions of requests without breaking a sweat? Load balancing is an absolutely critical component of any large-scale web application. By distributing workload across multiple servers, load balancing helps ensure high availability, responsiveness, and scalability. Understanding the core load balancing algorithms will allow us to better architect, troubleshoot, and optimize our applications. There are two main categories of algorithms, static and dynamic. We'll provide an overview of each category and dive deeper into the specific algorithms, discussing how they work and their pros and cons. Stick around to the end because we'll also summarize key criteria to help you select the right algorithm. So let's get started. Static load balancing algorithms distribute requests to servers without taking into account the server's real-time conditions and performance metrics. The main advantage is simplicity, but the downside is less adaptability and precision. Round robin is conceptually the simplest approach. It rotates requests evenly among the servers, sending request 1 to server A, request 2 to server B, and so on in sequence. This algorithm is easy to implement and understand. However, it can potentially overload servers if they are not properly monitored. Sticky round robin is an extension of round robin that tries to send subsequent requests from the same user to the same server. The goal here is to improve performance by having related data on the same server. But uneven loads can easily occur since newly arriving users are assigned randomly. Weighted round robin allows operators to assign different weights or priorities to different servers. Servers with higher weights will receive a proportionally higher number of requests. This allows us to account for heterogeneous server capabilities. The downside is that the weights must be manually configured, which is less adaptive to changes. Hash-based algorithms use a hash function to map incoming requests to the backend servers. The hash function often uses the client's IP address or the requested URL as input for determining where to route each request. It can evenly distribute requests if the function is chosen wisely. However, selecting an optimal hash function could be challenging. Now let's switch gears to dynamic load balancing algorithms. These adapt in real time by taking active performance metrics and server conditions into account when distributing requests. These connections algorithms send each new request to the server currently with the least number of active connections or open requests. This requires actively tracking the number of ongoing connections on each backend server. The advantage is new requests are adaptively routed to where there is most remaining capacity. However, it is possible for load to unintentionally concentrate on certain servers if connections pile up unevenly. Least response time algorithms send incoming requests to servers with the lowest current latency or fastest response time. Latency for each server is continuously measured and factored in. This approach is highly adaptive and reactive. However, it requires constant monitoring, which incurs significant overhead and introduces complexity. It also doesn't consider how many existing requests each server already has. So in summary, there are clear trade-offs between simpler static algorithms and more adaptive dynamic ones. We need to think about our specific performance goals, capabilities, and constraints when selecting a load balancing strategy. Static algorithms like round robin work well for stateless applications. Dynamic algorithms help optimize response times and availability for large, complex applications. Now, which algorithms do you think suits your needs best? Have you faced any challenges with load balancing in the past? Share your experiences and insights in the comment below. We'd love to learn from you, and we'll see you in the next video. you like our videos, you might like our system design newsletter as well. It covers topics and trends in large-scale system design, trusted by 500,000 readers. Subscribe at blog.bytebygO.com.